My name's Naveen, and today I'm going to be talking about Lab 3 for Physics 2212. So, introduction. The purpose of this lab was to explore the magnetic field created by a bar magnet. Well, I used many bar magnets, I think 6, and a model was created to predict the magnetic field in different locations. Some locations were on axis, perpendicular, and the main one was the 45-degree angle one. The physics principle involved was the Biot-Savart law, but this one was especially modified for magnetic dipoles. So experiment observations. These are just all my observations. The closer I moved my magnet towards the phone, the easier it became to increase the magnetic field strength, which just is a basic proof of the inverse law. It's also evidenced by my data. So observation statements, just a couple observations that I found. So when I brought the magnetometer far away from the magnet, it measures almost a zero magnetic field, as if the magnet wasn't present. The magnetic field definitely is present at the magnetometer, but it's so small that the app doesn't read it. So as the magnetometer moves closer to the magnet, the measured x component decreases. That's true. Phi value kept decreasing and becoming more negative. So the magnitude kept increasing. The position of the magnetometer did have an effect on the measured x component because when I moved it perpendicularly up and down with respect to the magnet, it changed. So the graph that I got from my spreadsheet, the graph shows n as 3.3776. I rounded n down to allow the r cubed terms to cancel each other out when I'm solving for the magnetic dipole. So k came out to be around 1.7 times 10 to the negative 7th. That's just e to the slope intercept of this equation of this graph. So I set k kr to the n equal to the on-axis dipole magnetic field equation, which is u naught over 4 pi times 2 times the magnetic dipole moment over r cubed. And I solved for the magnetic dipole moments, which ended up being 0.8589. So this is all my data for the 45-degree experiment. So the average value for the magnitude of being at 45 degrees was 5.1 times 10 to the negative 5th. So from the model, I first set the mu mag to my calculated value, and then I changed the dipole B function to reflect the formula that was given for the magnetic field for the magnetic field created by a dipole. I changed the B scale to 1,000. I changed the B scale to 1,000, and then the distance 0.14 that I chose was kind of arbitrary. I just made it close to my D perp, so the scale would work out. After this, I had to define R axis 1 and B axis 1. And so for R axis 1, it's just observation axis 1 minus the position of the magnet. And then B axis 1 is just the function. I just inputted magnet.mu and R axis 1 into the dipole B function. And then I changed the axis to B scale times B axis 1. And then I did this for R axis 2. And I also did it for all the R perps. So finally, I inputted my D perp value that was observed from my spreadsheet. I just put the same value in. I used the average value for all 3 trials. So that was 0.15917. And then I updated the code for R 45 degrees, which is just observation location at 45 degrees minus magnet position. And then for B 45 degrees, I just put both those values into the dipole magnetic field function that I created earlier. So model results, this may look wrong at first because the blue arrow at the origin points to the left, but that blue arrow at the origin is the arrow in the z-axis, so it's actually accurate. And you can see the purple arrow on the top right, which is the 45-degree angle experiment. So the data observations versus the model for the 45-degree observation. So the z value in the model is 0, and in the observations it was not. That's just the major difference between them. Otherwise, they were pretty similar. What if you hadn't oriented your experiment to compensate for magnetic north? The results would be slightly skewed because the distance values would be larger, smaller, depending on which direction the magnetometer was angled. There would be an X component on the magnetometer that reads even when the bar magnet is not part of the system. Well, if you were to stick two identical magnets together, the dipole moment would be doubled, and the magnitude of the magnetic field at all points would also be doubled as a consequence of this.